Today I'm going to talk about generative AI in development processes and dev tools for this. My name is Bohdan Snisar. 14 years of software engineering experience, had different roles: software lead, engineer, CTO, remarkable companies. It's Revolut, Wig. Currently partnered at Overview. It's consulting for LLM and machine learning research and development of products. Co-founder and CTO for Red Space, fashion search and discovery platform for finding clothes. Here's my links. Feel free to follow. Okay, let's start. Before diving into the details, I want to just highlight and group projects into several areas. It's a taxonomy of usage of AI for system operation and software development lifecycle. There is 4 groups that I find out reasonable here. Conventional systems with conventional SDLC. This is where most current software lives. Standard systems, like traditional inventory management systems, using standard development processes without any AI. Some legacy. Conventional systems with AI-augmented SDLC. Emerging area where tools like GitHub Copilot or something similar used by developers. Could be just any project, and this is the area where I want to concentrate further during this talk. Another area is actually some where people developed exactly AI systems itself. AI-augmented systems with conventional SDLC. Kind of idea of having ML-based product in production, but using the same SDLC as usually. And just the combination of everything when we developing AI product and using AI tools for SDLC. As we see, SDLC it's a part common for everything and where AI development's really interesting for me. And I want to share my experience from what I used and what looks reasonable at this current moment. What's SDLC itself? It's a process that contains from different phases. It's not only coding. It starts from requirement analysis. Just we need to plan what we going to implement, then development process, then testing, integration testing of it, deployment into the production, and maintenance of it. This is the SDLC overall. Interesting to see what actual researchers trying to solve, where the current trends and what's happening. There is an interesting paper that summarizes, pretty fresh, that summarize the whole number of white papers and researchers that happening across the whole internet. They find out that a majority of things concentrated on software development itself. Different angles of it, I will cover a couple of them. But there is a developments in software maintenance, requirements engineering, software design, software management. Looks like in the SDLC process there is 2 emergent parts. It's coding and maintenance. However, in the proportion, I believe maintenance it's bigger because we have a lot of already written software that requires maintenance. And that's interesting that problems mostly concentrated on generation. Problems, but tasks that researchers try to achieve. It's a generation of code, generation of different things. Recommendation and some classification things. Let's think about what ideal product or what's actually some people envision as a dream about software development. It's a fully automated SDLC. That's a set of AI agents that's responsible for operating independently and makes the SDLC autonomous. Starting from role assignments, requirements engineering, development, testing, deployment, and all other things. Currently looks like we can use LLMs during SDLC as a helpful tools to reduce human errors or make our work easier in some way. Moreover, there is some, of course, rumors about autonomous software engineer as a service, for example, Divine, or open sourced SWE agent. This is a set of AI agents that can reflect software engineer. Or they try to do that, and according to the test, it's not works so well. In reality, this agents, it's just a dream right now. However, we see that this chance will continue. And who knows what happens in 2030s. Instead of trying to replicate the whole software engineer as an agent, there's a reasonable to have it split it on several functions and maybe to automate or create helpful tools for part of the SDLC. First thing that comes to me, it's planning. There is a requirements engineering phase where we need to gather requirements and understand. There's an interesting quote: if my job was coding solutions to problems with rigorously defined requirements, that would be concerning. It's about that people are pretty bad in expressing what they want and like developers say. I think opposite. LLMs are really good in understanding of some unstructured requirements into some structured way. This is a really good thing for requirements engineering. It can be used to interpret unstructured requirements into the text specifications or even user stories in reality. LLMs can help requirement engineering to highlight unknowns. It's actually important thing. It can navigate to some gaps into the requirements that actually not so visible, or it's hard to understand that these gaps exist just because LLMs has some generic knowledge and it could be used to fulfill those gaps or identify them and uses as a knowledge for follow-up questions during the requirement phase. And another interesting point is to classify functional, non-functional requirements from different sources, from, for example, user reviews on the platforms. It's actually interesting thing that LLMs can be used to identify requirements based on the user feedback and just create already fully refined or halfly refined tickets that already ready for grooming phase or planning phase, or at least to create them into the developer's pipeline. So requirements engineering, it's an interesting thing. Another, of course, part is the development. How LLMs used in software development. There is a lot of directions where research happening right now. It's a code completion, summarization, search, code understanding, actually pretty important, program synthesis, API recommendations, API kind of generation, also interesting, and I guess here it's emerging problem exists, method name generation, etc. That's nice. Moreover, there's only two hard things in computer science, according to the quote: cache invalidation and naming things. And naming things already not a big problem, according to the LLMs. What tools I'm personally find out interesting? It's a Replit, for example. In reality, it's a reflect of AI agents that tries to build some ready-to-use solution. It works only for Python and JavaScript. Majority of LLMs well trained on these things, and it's really bad actually for some rare languages or complex languages like Rust. What this tool good for? It's for prototyping, for something to show as an idea, as a concept. It has a lot of nice standard use cases like authorization, authentication, access to the database, and it's time saving for fast prototyping. And it's pretty crappy for specific use cases. When you try to do something not specific, it's a bit problematic. Cursor, it's actually not a platform, it's a tool. It's a kind of a VS Code fork that had a lot of recent developments with code completion, assistance for code. We can refine and ask it to do something, to modify code at different angles, and it's pretty nice actually. However, it's not so good in working with big projects. So my current activity, when I copy-paste something to the cursor, work with it, and then copy-paste back to the IDE or VS Code. The reason, because I can do the same with ChatGPT, but with ChatGPT I need to every time write some specific prompts. Here it's a tool that likes designed to work with code. So in some way useful. That's mostly my main usages of LLMs in software development. There is a GitHub Copilot, but I cover it in the next phase. What about maintenance? There is actually a really good fit for LLMs. Program repair, detection, review, debugging, bug reproduction. It's interesting direction. Hope there will be some interesting products there. Logging, another interesting idea that we can automatically augment software code with logging, because usually software developers put logging randomly without any kind of a system. Either it's some problematic place or there was a bug or something like this. If the LLM can make it automatically and put it with the understanding of the context, it's really nice time saving for maintenance especially. Bug triage, also a nice thing, actually a good fit for LLMs. Another interesting thing for maintenance, it's a search, how to find something across the whole part of the project. It gives ability right now to merge and join a lot of piece of information together and make it as a useful information to help to solve something. It could be specs, Jira code, test cases, bug reports, documentation, etc. Just something can give you the answers based on it. There is a couple of products that working with this. I actually work on the with GitHub Copilot workspace, but there is Atlassian Rovo, not used, but interesting to see, Nabu AI, and GitHub Copilot. In some way, it's interesting. Right now, it's mostly good for finding. However, GitHub Copilot tries even to give you ability to add something. For example, you express, you have a specification, then you want to add some specific details, and this thing can generate code based on it. This part works, let's say, okay with small classes. For specific cases, it's a bit problematic. It's problematic. Just because it can lose the context or don't understand the whole context of the problem clearly. But the ability to merge information really nice. Another thing of maintenance, it's working with pull requests. Actually, this is a nice thing. It's a GitHub marketplace, CodeRabbit, AI. It's nice. Actually, it helps to analyze code and makes pull requests review really good, because sometimes it can find what I missed. Sometimes I find what this tool missed, and this is a good combo in reality. Just because it's just a real healing of Copilot. Another part of maintenance, it's working with issues. There is a just example, GitHub Marketplace 2, DosuBot. It can work with issue requests, and it tries to resolve this issue as answering to the question. Sometimes it makes a good job in getting answers, especially with analyzing the code base and resolving some issues without human interaction. Pretty nice, actually. The idea, good. Another real direction where it works for maintenance, it's a documentation. Usually, developers dislike write documentation because they become outdated pretty easily. However, with LLMs, I guess it's a good direction. I just don't use any tools except ChatGPT, but it's nice thing, especially for code comments and reflecting README and documentation with code. So we just changing the code and documentation reflects it without our interactions. Maybe just only with some supervisory. However, no tools here. Another really nice thing, it's tests. That's a really important part of SDLC, and here the LLMs are really powerful and see a really big value of them. It's a test generation, verification, test automation, a lot of things actually. Why it's so good? Because edge cases, what I think, and edge cases that LLM can generate is quite bigger. So it's really nice that it can generate more edge cases that I usually do. And that's really helpful in this case because it also helps to navigate some gaps in understanding. Proven clear value works not only for unit tests, but works for Selenium tests. It can be used, especially right now, they can understand a visual part. So it can be used for writing some Selenium specifications that gives you ability to test application end to end and to reflect it. Someone can be called that TDD not so aligned with these developments, but I would say even with current capability, these LLM tools can at least cover and increase test coverage for code that make it more maintainable. It can detect changes and improve overall code quality. Another good example is auto paper by Meta about automated unit test improvement using large language model. They created a pipeline that's responsible to improve test coverage, just as we discussed previous slide. The idea is that it generates test cases, not the unit test, but actually try to understand what to test to fulfill the ideas or like specifications for test. Then it's doing some pre-processing of it, then generate tests, runs builds, and when this build passes, means this is already successful number of tests. Then post-processing is improving of code coverage, and here we are, we have a ready to create the pull request. A really nice paper that says that Meta itself internally tries to uses for different cases. What we can summarize here, it's interesting that for code writing, it's not so bad. It really helps for boilerplate and repetitive code tasks. It's good for changes to end user code, actually. When it's not about complex things, when it's just for some small part of it, for some class, it can be useful. It's really nice for test and especially for test data generation, because sometimes it's really hard to generate some test data or come up with it. You need to think about it. Here is really proven value. It's nice for assistance in unfamiliar tasks. It's another interesting part when LLMs can be used. For example, CSS for HTML generated even though that you don't know CSS, like CSS for backend developers. That's nice. I tried even with ChatGPT. It works. After some number of iterations, I can manage to write some specific cases that I'm not familiar with. And it's really good for integrated search over data lake. It's a really emerging thing, especially for big projects, because in big projects, the issue of complexity between different parts is really big. It's not good for changing a complex code. Yeah. And it's not good for refactoring, because refactoring requires changing with understanding of the big context. For maintainability of complex legacy code, it's not so workable. And of course, it's not good for generating a complex code or like code for multiple cases or even multiple classes when they're involved in this. In a nutshell, it works great right now for unit tests, for testing, let's say. It works great for some prototyping, and it's not so good for maintenance of the legacy or big projects. Yes, we heard about recent talks that, for example, Amazon just save a lot of hours for migrating from one version Java to another, but in reality, I think it's just minor code changes, because migrating from one version Java to another, not so complex. Just the language really famous for their backward compatibility. So this is the kind of a summary that I see reasonable right now. What else? What interesting side effects this thing creates? One side effect I see, it's code churn by years. There is a article that, this article will use some extrapolation, but in reality it says that code churn increases after the LLMs boom started. There is a couple of comments, and the idea is that practical consequence of LLMs that it works well for experienced developers, but for newcomers it becomes a bit problematic because LLMs generate some code, but you need to understand is it okay or not, how to modify it. And it requires experience to work with it. And usually it generates something that's not really nice, or it's nice but partly. And it means if we really follow the LLMs without any supervisory, it creates legacy code quicker than people usually do. This legacy code will be problematic for next maintainability, the maintenance of it, debugging and fixing this code. It means LLMs good for generating code, but this code has a higher efforts on maintainability. And this is a problem that actually could be, and where I guess some researchers will try to solve, because new code generation, it's nice, but maintainability of it, it's another important part, because it's a really big part of overall life cycle of the project. This is an interesting outcome that I see even with my code, that here is the emerging thing. However, it's all my story right now about the usage of LLMs and things for DevTools. So thank you for your time, and I hope it was interesting to listen.